All right, welcome back, everybody. We are in the second section looking at Learning Target 2. This is going to be the second major part of your exam, and it is, of course, involved with can we complete the square? Let's go through some of the steps leading up to it, and then finally the whole process of completing the square. And we'll do that by heading over to problem number 11. I'm going to remind you that on your exam, be careful with the directions. It's really easy to start a problem and go way too far, make a mistake if we don't read what the problem is asking us to do. And number 11 is really simple. It's just asking, what do we need to add to both sides to complete the square? What I'm going to do is, like I usually do in class, in green, I'm going to write down the little expression we need, which is b over 2 squared. This represents the number that we add to both sides to complete the square. And I'm going to fill in from the problem. So if it helps you, you can label the 1 as A, the 10 as B, and the constant number as C, although it would actually be its negative. But B right there. Let's use that. So moving into our expression here, b over 2 squared is actually going to be 10 over 2 squared. Simplifying that one more step, 10 over 2 is 5 squared. And just out of habit, you may know why I'm doing this now. I'm going to go ahead and highlight that 5. Even though we don't need to for this problem, it's a good habit to have because we're going to need that 5 for the shortcut if we kept going. For this problem, though, it ends up really easy because 5 squared is 25, and that's our final answer. That's the number we would have to add to both sides of the equation if we wanted to keep going. But it's only asking us for the number, not to keep going, so we'll stop there. We'll keep that in mind, and let's head over to problem number 12. This one does say to finish it all the way through. Solve the equation. Find the solutions to the quadratic equation by completing the square. Let's begin. The first thing I want to check for is, do I have all my x's on one side, x squareds and x's, and do I have all my constants on the other side? And it looks like the 3's in the wrong place. This is like if we were setting up for a stage, for a show, and I'm telling, hey, 3, you're on the wrong side of the stage, dude. Let's move you over. So let's do that by canceling the 3. And whatever we do to one side, we do to the other side, subtract 3. These will cancel, and this will set us up for success because now we have x squared plus 6x. All the x's are on one side, and that's going to equal 0 minus 3, which is negative 3. And we have all the numbers, the constant terms, on the other side. Now we can start. Let's use that expression we needed from the last problem. We're going to use b over 2 squared. And looking, it looks like our b is going to be 6. Let's use that in here. So we'll have 6 over 2 squared. Or in other words, 6 divided by 2 is 3 squared. And don't forget, we're going to need that 3 for the shortcut later. Let's highlight that and keep it going. 3 squared is 9. So it looks like we're going to need to add 9 to both sides. And you know what? I'll go ahead and write that 9 in orange just so we can keep things color-coded. Next step is we're going to copy this equation down here. In fact, I'm going to go ahead and just literally copy it. But I want to move this over because I'm going to need some space to add 9 on both sides. So I'm going to scoot this here. And let's go ahead and add 9 plus 9 plus 9 to both sides. We have just completed the square because this trinomial here is now a square term. To factor that as easily as possible, let's bring down our parentheses, put a square on it, and remember, we're going to use the same variable we've been using, x, and this is a positive 3. We highlighted that earlier, so we can bring down the plus 3. That's a shortcut to factoring the trinomial that we have right here. The other side is going to come down. We're going to bring down the equal sign. Negative 3 plus 9 gives us a 6. And this looks really, really similar to a problem we had a few problems back, looking like maybe problem 6. So let's do what we think we should do. Let's take the square root of both sides. Square root on both of them here. The square root's going to cancel the square, of course, and we can bring down nice and easy x plus 3 equals, don't forget, we're going to have positive or negative. And when it comes to radical 6, square root of 6, we can't simplify it anymore. I'm trying to think what's the biggest perfect square that divides 6, and there isn't one except for 1, which we're not going to use here. So in this case, the square root of 6 just comes down, radical 6. We're still trying to get this x by itself, so let's cancel out the plus 3. So we'll subtract 3 from both sides. The 3's would cancel, and we end up with the equation x equals positive and negative square root of 6 minus 3. We're going to break this up into the two equations, one with the positive and one with the negative. And let's get those down here. I'm going to keep these color coded where I'll keep my purple positive. So I'll have x equals positive radical 6 minus 3. And if you're thinking there's something we could do there, can we subtract? Can we put these together? Can we do something? The answer is nope. We can't simplify that anymore. If you pump that into your calculator, you're going to get a long decimal, which we don't need. We just want to simplify it as is. Let's go get now the negative answer. And I'm going to put that on the side here. X equals, and it'll be now negative radical 6 minus 3. And again, there's nothing we can do about it. We can't simplify that any further. So that answer stays locked. Let's zoom out and let's keep it going in the same section, still looking at complete the square problems. We're going to head over to problem number 13. And here we have an error analysis. Let's take a look. Like I said before, one of the easiest, best ways to do this is to do the problem yourself and see if your steps match up with what's going on in this student's solution. So I'm actually going to do here, just to give me more room to write, I'm going to give myself the biggest pen I can, and I'm going to change this color to white because I want to use this space right here where the Let's Go Mr. Pause is hanging out. And let's see if we can use this space to give us some room to work. Well, let's make the pen a little more reasonable. And I'm going to copy the exact problem so I could start it on my own. I'll have x squared minus 8x minus 9 equals 0, and let's begin. First thing I want to do, I want my x's on one side and my constants on the other side. So let me cancel that minus 9 with the plus 9. Whatever we do to one side, to the other side, plus 9. The 9's cancel. And we can bring down nice and neat x squared minus 8x equals 9. I can already see we have the same step here and here. So far so good. Let's keep it going. Next thing, I would like to find what number do I need to add to both sides. To get that, we're going to use, again, b over 2 squared. Finding b, it's negative 8. So I'll have negative 8 over 2 squared. Moving that over, that's going to be negative 8 divided by 2 is negative 4 squared. I'm going to mark that negative 4 with my highlighter so that I can, oops, I think I'm having issues with my stylus. One second, guys. Let me reset my stylus. Oh, I see why. Okay, my stylus is having a little bit of issues, so why don't we just box that off with a pink square? Maybe a red square. And then moving along, negative 4 squared, that's negative 4 times negative 4 is 16. Let's bring our equation down here. So we're going to add that to both sides. We'll have x squared minus 8x. I'm going to give some space, and we'll put equals 9. And here's where I'm going to add the 16 to both sides. I'll put plus 16, plus 16. And remember, we have a shortcut for factoring this. Even though we've practiced this before, we've done this, you don't need to do the x game. You don't need to go that far. We can bring down a parentheses with the same variable, x, the same number we have over here, minus 4 squared equals, and 9 plus 16 is 25. Just checking what we have here. So it looks like our work here is matching the work here. So we're good so far. Let's keep it going. In the last steps, we're going to take the square root of both sides. Square root cancels square root, and we're going to have x minus 4 Equals, don't forget, positive and negative. Square root of 25 is 5. Let me make that a little better looking. Trying to get x by itself, we're going to add 4 to both sides, plus 4 plus 4. The 4's will cancel. And we're going to end up with x equals positive and negative 5 plus 4. I'm going to scoot over just a bit here. I'm going to give myself some room on this side where I can have my two answers. I'll take the purple one and the green one will go down here. In purple, let's do the positive. So we'll have x equals in positive 5 plus 4, which is just 9. One of our answers good to go. And then in green, we'll have x equals negative 5 plus 4, which is the same as negative 1. And we'll lock that one away. And let's head back. Let's see if we have our two answers. Looking over here, it looks like we have x minus 4 equals positive and negative 5. Okay, we got that far. That's right there. And it looks like then we have x equals 4 plus or minus 5, which is the same as this step here. X equals, you could see they put the 4 in the front and then the 5 in the back, but it's the same thing. So I don't think there's a mistake in this problem. I think 4 plus or minus 5 is the way to go. And I would leave this as determine the first mistake made when completing the square. I think there's going to be no mistake. Make that a little bit nicer. And we could drop it off there. All right, that concludes this section. I'll see you guys in the next one.